Okay guys, so this is, we're still on the demand worksheet, and this is kind of a long question, question 41. So I'm just going to make this video all about that, and then we will do one more video to finish off the worksheet. Okay, so assume the demand for ski poles in a small town is represented in the table below. Okay, 0 is 200, all the way going up in increments of 4, prices going up in increments of 4. When we get to 40, and the quantity demanded is 0. Okay, now, using the information in the demand schedule above, derive the demand function for ski poles expressed as QD equals A minus BP. I prefer plus BP, but whatever. Okay, now, the first thing I've written, so just to be clear, at a price of 0, 200 is the quantity. Okay, that's the first thing I want you to know. Okay, so therefore I've written down here that A is 200. Right, so that's one thing that we can immediately know. Now, QD therefore equals 200, and I'm going to write plus BP. All right. Now, another thing that we can use here is, and I just see it. I'm not going to use the 0 for. Well, I can actually, but well, I can, but I'm not going to. What I'm saying is, we know that at a price of 36. 20 is demanded. So I'm trying to, get you guys used to this. So 20 is bought, 200 plus B times at a price of 36. Okay, so we've got 200, sorry, we don't. We've got 20 equals 200 plus 36B. Okay, so what I'm going to do now is I'm going to bring this over. I'm going to say minus 36B equals 200 minus 20. Minus 36B equals 180. So now what I'm going to do is I'm going to just rewrite this bit here, 180 over minus 36, and I get just 180 divided by 36, and I get 5, but there's not 5, so I get B equals minus 5. So the function now is QD equals 200 minus 5p, and that's the answer. And I hope you could see that, all my calculations there. That is the answer. I'll just move this camera a little bit. That's the answer to the first part. QD equals 200 minus 5p. Now, on to part B. Right, draw the graph showing the demand for ski poles on the axis provided below. Now, it might be a little bit tight on space. So we know that P equals 0, QD equals 200 is on that for a number of reasons, right? And the thing is, we've got the table, so we don't really need to do any of this stuff. So we've got, there's one thing, and we've got 40 and 0 is also on it. So if I can just get this ready. So we know that 40 and 0, just want to make sure you can see everything. 40 and 0 is on this. And then it was 0, 200 is also on this. Okay, so and what I mean is on this is on the line. So we know that all we need to do is draw 2 dots, and we've drawn it. Okay, now we'll be referring back to this diagram, or just this one demand curve quite a bit. Okay, so that's that one. Now, on to the next one. Okay, C. Assume that due to an increase in the popularity of snowboarding versus skiing, okay, they are substitute goods, the demand for ski poles decreases because people are buying more substitute goods, they're buying more snowboards, so therefore they don't need as many ski poles. And at each of the prices on the original demand schedule, which was the previous one, why not, now that we're here, which was this one here, at each of the prices, what does it say? The quantity demand is now 40 units lower than it was previously. Create a new demand schedule. So what I did was, and I'll probably bring this back here. I took each of these and I wrote them all down, as you can see, up till I stopped here for a reason. And I took 40 away from all of them. So we've got 160, 140, 120, 180, 60, 40, 20, and 0. Okay, so that's what I've done now. And then it says, derive a new demand function based on the information. Right, well, as always, right, I keep on putting this down to save time. So we've got QD equals 160 because that's why, because at a price of 0 now 160 is bought. QD is 160 plus BP, right? And then I'm just telling you, you can do this for any single one you want, right? Any single combination of price and quantity. I will choose this one for no reason other than the number 100 appeals to me, right? So I'm going to say, okay, at a price of 12, 100 units were bought, right? So I'm going to go 100 equals 160 plus B times 12. So that means 100 equals 160 plus 12B. I'm going to bring this number over here, right? And I get minus 12B equals 160 minus 100. Minus 12B equals 60. So I'm going to divide, just write this out here so you can see what I'm doing. And I hate it when I do that. I'm sorry, guys. It was 60 divided by minus 12. I'm dividing both sides by the number before the letter I'm trying to find. And I get B equals 5. Now let's look at this and let's compare. The price increases have been going up by 4. And the numbers have been going down by 20 still. Okay? So therefore, the slope is still the same. Okay? And don't forget it's a minus. Don't make the silly mistakes that I make. Okay, equals 160 minus 5p. The slope is the same. It's absolutely the same. But the curve is shifted inwards because the demand for a substitute good has increased. All right, now, on to this. Yes, excellent. All right. So, just to read this so we can. On the axis below, plot the original demand curve and the new demand curve. Right, well, I'm going to plot the original demand curve first. Why not? Because I want to compare them, all right? So what we've got is 40, 0, 0, 200, right? So I'll just quickly, oh, for God's sake, silly me. There's my 200. Okay, excuse me, guys. And then there's 40, 0, 0, 200, right? No problem. There we go. That's the original demand curve there. That's your D1. Now, however, this one, we have 160, and then at a price of 32, we're at 0. So the price of 0, we're at 160. Just going to write that in here. There's 160, and at 32, we're at 0. All right, so let's draw these down. Now, if I've labeled everything correctly, they should be parallel, and I think we can see they are. Okay, they have the exact same slope, same distance between them all the way along. They'll never meet, and what that is an inward shift of the demand curve from D1 inwards to D2. Okay, that's what that represents. Okay, now that's excellent. I've done all of that. Okay, so we are on to question F. Okay, now assume that due to rising incomes, skiers in the small town become less responsive to changes in the price of ski poles. Therefore, for every $1 change in price, the quantity demanded changes by less than it did before. Well, let's check out the new demand schedule. So instead of going down in 20s as we were, it looks like we're going down in 16s, I believe. Okay, so that means that the slope is changing. All right. Now, let's quickly work this out, okay? So what we've got here is we've got QD equals 200 plus BP. Well, how do I know that? Well, at a price of 0, we're back to 200. That A variable, that A value, is the amount that's bought at a price of 0. Now again, right, so I can see, I'll choose a horrible one here. So at a price of 24, 104 units is demanded. So 104 goes here, equals 200 plus B times 24. Okay, so I've got 104, 104 equals 200 plus 24B. I'm going to bring this over, so 24B equals 200 minus 104, and I believe that's 96. 24B equals 96. Forgive me, guys, I just don't want to make a mistake. Okay, minus 104, and it is 96. Okay, we go up here, and I go 24B equals 96, no problem with that. Divide by 24, divide by 24, I go 96 divided by 24 equals 4. Okay, cancel, cancel. B equals 4. That means the number before the P has changed. Now, explain what has changed about demand based on your new demand function. The B variable has decreased as buyers are less responsive to a change in price. Now, instead of buying 5 fewer units for every $1, that was the previous B value for $1 increase in price, consumers buy 4 fewer units. It has become less sensitive to a change in price. Okay? Now, I seem to be losing my mind with the graphs here, so I seem to be asking for graphs all over the place, right? So on the axis below, plot the axes below, plot the original demand from part B and the new demand based on the function you derived in part G. Well, we can plot the original, and I hope we're getting kind of bored of this because it was 40 and 200. Okay, so here's my 200 and here's my 40. Now that the B variable has changed, we know that the slope will change. It has gotten smaller. It was 5, okay, it was minus 5. Now, I should actually write this out. QD equals 200, and it's not, it's flipping well minus 4p, okay? So will it become steeper or will it become flatter? All right, now what I'm going to do is, will this work quickly? 40, yes it will. So I'm looking at this here, and I see at a price of 40, 40 units are demanded now. So I'm going to say, okay, I'm going to put 40, 40, because we know that 200 is there because it's the same A value, but at a price of 40, I'm going to go, this is 45, this is 40, at a price of 40, it's here. So as the number before B, which is before P, which is the slope or the B value, has reduced, what has happened? Okay, well, it's gotten steeper, and that's what's happened. It's gotten steeper, and that's what happens whenever the B value or the slope gets smaller, because technically it's really not the slope, it's the inverse of the slope, but we won't worry too much about that. And when asked for what the slope is, you will always answer the number before P, whether you're talking demand or supply. Okay guys, we'll leave it there. Just one more video to do to finish this worksheet.